My name is Morten and you are watching Frost Astrophotography. Welcome to PixInsight tutorial part 2, Pre-processing, Image Approval and Integration. Before we get started in this part 2, let me make a short recap. In the first part, we integrated the dark frames into a master dark. We also integrated all our dark flat frames into master dark flat frames, one for each filter. We then used the master dark flat frames to calibrate our flat frames, again, one for each filter. We then used the master flat frames to calibrate our light frames, also one for each filter. And then we ended up with a folder here with calibrated lights, 91 in total. The next step in this part 2 of this tutorial is to register the light frames using the star alignment tool or process. But before we can do that, we want to make sure that we only use the best and approved light frames, because you might have light frames in there that are out of focus or contains other types of unwanted structures like clouds and things like that. And we don't want to use those because those will degrade the result of our final image. For that, we're going to use a tool called a subframe selector. Now, the subframe selector contains 3 different windows. As you can see here, it says that your file could not be accessed. This is for showing the actual diagrams in this tool, and this is because I'm running this PixInsight on a Windows version in the Swedish language, and I've used a non-allowed character in my username, and that will result in PixInsight not being able to display it correctly. I'm going to show you this diagram anyway, because the file is actually present. It's just that it can't be showed in this dialog window. But it's not critical for this video. We're going to use the numbers in this Excel sheet or in this spreadsheet view to be able to process and make decisions. So what we're going to do here, now this is old data, don't worry about that for now. In this subframe selector window, you will actually add the files that you want to measure. And we want to measure our calibrated lights, like the ones we calibrated in the first part of this video. Now, configuration wise, you want to choose a routine that says measure subframes. And you will have to configure your system parameters. The subframe scale is actually the image scale in arc seconds per pixel in relation to your main imaging camera. There are several ways of knowing what this is. You can use some online tools like astronomy.tools, I think it is. You can go to calculators and this CCD suitability. That's one way of doing it. you will select your telescope. I have the Skywatcher ATED. I have the 294MM Pro. I have a 600 focal length default, but I also have the reducer 0.85. And this will get me to a 1.87 per pixel. So I'm typing in 1.8700 arc seconds per pixel here. Then you should also enter your camera gain. You can know this by opening up one of your light frames. That is, if your acquisition software and camera allow it. Go into the file, look at the FITS headers. You would see the gain number here, 1.00224268, etc. And you type that in. If you want, you can leave this at default settings, but that will actually just allow you to look at the quality of images in relation to each other, not in relation to actual measurements or the correctness of your data. You can make some changes if you want to your star detection parameters. You can copy mine if you want. I think I've edited some of these settings. As for the rest, I keep it as default. So when that is done, you just click on the Apply Global and let it work through your light frames to gather and measure the quality of your data. So when that is finished, you can drag the columns that you want to look at to the left. The FWHM, that is basically how sharp the star is in relation to focus and seeing. The eccentricity is a measurement of how round the star is, the shape of the star. The number of stars in the image, I think that is a very good parameter to also look at, because that is fact to how many stars you're actually identifying, and the more stars you identify in a frame, the better the quality, the seeing, the less clouds, everything like that, I would say. So that's basically the things that I'm looking at. And then you have a weight column here. It's all the same right now, but we're going to put in a weighting expression in this tool to put numbers here that we're going to use later on when we integrate our light frames. So the first thing we do then is to, like you see now, all 41 frames are just listed. We can also, if we want to list them by FWHM, for example, and ascending, you will see the one with absolutely the best quality at the top in regards to that, and the one with the worst quality in the bottom. You can also see that directly, I would say, relate to number of stars, because in this image where we have the lowest FWHM, that stands for full width at half maximum, I think. I will not go into any technical details about that either, You can find YouTube videos. Adam Block has a good one, or several good ones on this subject, talking for hours. You can watch that. But you can see if you have a low number for the FWHM, you also have a large number of stars detected. If you compare that to the highest FWHM, the probably lowest quality of image, you have 2000 stars in relation to 4,500 stars detected in this image. You also have a low number of eccentricity, and here as well, the lower the number, the rounder or better quality of the star. I would say the shape of the star, I'm not going to lie. So detectable for the human eye, I think it's somewhere around 5.5 or something like that, or maybe 5. Maybe for the trained eye it's a bit lower, but above that you will start to see oval shapes, not round shapes on the star. So there might be 1 or 2 here. I think the numbers are pretty good in regards to eccentricity for all of my frames. Keep in mind also that the FWHM, the prerequisites for having a good numbers here also depend on the type of equipment that you have. Your telescope with your focal reducer and flatteners, the camera, the pixel size of your sensor, and the image scale, arc seconds per pixel. That also determines what's the minimum FWHM that you will be able to get with your equipment. So some might say that even what I'm considering to be my best image is not good enough in their world. So I would say, yeah, I think you will have to treat these numbers in regards to the possibilities and within the frames of reason that you have for your gear. So what we're going to do here now is we're going to use the third window, the expressions. We're going to paste a formula of weighting in here. Now this is a very long and complicated and complex formula. I'm going to include this in my video description so you can copy it. I'm just going to clarify that I'm not the author of this expression. It's a combination of expressions found out there on the internet and that other people have made. I don't really have any programming skills, but the weighting expression is actually going to put numbers in the weight column here, and those are going to be used in the final step where we actually integrate our light frames. And the light frames are going to be integrated using the weighting. So more of the information or more weight is going to be put on the light frames with a higher scoring in the weight number. And to be able to get that weight number, we're going to use the FWHM, but we're also going to use the eccentricity, and we are going to use the stars. And we're going to use a different portion or a different percentage of those numbers to be able to calculate the final weighting score. You can use only one of these, but I would say stars is normally not used in weighting, or many people don't use it. PixInsight will not actually use that by default in any case. So I think it's a good indication of the quality of image How many stars is detectable in your image? So paste that and click on execute. As you can see here, we now have a weighting score in this. Now we also want to add expressions to approve or not approve. So how do we select the images that we want to keep? We have discussed the FWHM. You want as a low number as possible. We have discussed eccentricity. You also want to have as a low number as possible. So I've pasted another expression here. Basically, you just use the FWHM smaller than or larger than a number. And if you want to add another expression, you do and. Eccentricity smaller or larger than a number. So I would say start with an FWHM smaller than 7 in my case, and an eccentricity smaller than 0.65 in my case. I click on the execute, and then it removed just one single frame. So if I do 6.5 here and 0.6 there, you can see that it removed a few of these frames as well. Now if you have a graph here, if I select FWHM, like I explained, this file could not be accessed, so I'm going to open it manually. This file is actually located in your temporary folder for your username. So you can open it up and then it looks something like this. But if you haven't been using any illegal characters in your username, you will see it directly in your PixInsight dialog window. So here you can see that you have the FWHM in relation to all your images. You can see how it changes during the session, and you can see what images have been excluded due to the expressions that you have made. I usually more use the chart or the spreadsheet to make my decisions, but the next step here is then of course to decide if this is the approval rate that you want. You can also open up these frames and manually inspect them, of course, if you want to. But if you decide that this is actually the frames that you want to keep, I would say go into your light frame folder, make a new folder and call it approved frames. Select that directory in your dialog window, approved frames. You can call it approved light frames or anything like that if you want to. The important thing here is that you add a weighting keyword, ssweight, that is the default. It will be added as a fits keyword name together with the weighting scoring that you see here. We're going to reference to that later on when we integrate our light frames, and this value or this weighting is going to be taken into consideration when integrating the light frames. So if you're happy with this for these light frames, H alpha, we can continue. But just to point out that the best frame here, we're going to open up a notepad. I'm going to type in H alpha, and that is frame 2751. Now this is the best quality light frame for H alpha because it has the lowest FWHM and the maximum amount of stars, one of the best eccentricities as well. So let's keep this in mind. We're going to use that as a reference later. Going back to the subframe selector main window, we are going to select output subframes instead of measuring. And then we're going to click on the apply global. What will happen now is that in your approved light frames folder, it will actually copy your light frames, the ones that live up to the approval expressions that you just typed in. It will add a _A for approved. So this will be a calibrated and approved light frame to be used later on. Now we switch back to measure. We clear this list. Then we add our next filter frames, which is 03. We don't change any settings because we have just switched back to measure subframes here. And then we click on the apply global to start measuring those subframes. Now that is finished, and you will see that if I keep exactly the same settings, these frames were not exactly as good as before. I don't know if I had bad seeing or if I was slightly out of focus or something like that. I would suggest maybe adding more data from other nights. For the purpose of this, I will change the FWHM to 7 here, and that will approve some more of these frames. The eccentricity is fairly good here, so the shape of the stars are good, but not the FWHM. I'm going to approve 18 of the 25 frames for this batch. I'm switching from measure to output. I'm keeping the exact same folder, the same keyword, and apply global. When that is finished, I switch back to measure again, clear this list, and I'm going to add my last calibrated frames with the S2 filter, and apply global to measure these. So this is finished, and using the same expression as my 03 filter, you can see that all are approved. If I decrease this to 6 instead, I will have 20 approved frames, and that will exclude the worst of them. So I'm going to make a note of this, and I actually forgot to make a note for the 03. I will go back and do that. But for the S2, I would say the best frame is 2807. And then I'm going to output subframes and apply a global. I'm quickly hoping that it will still keep it fresh in the computer memory. I'm going to remeasure the 03. Yes. And did I use 7.5 there? Something like that. Well, the best frame for the 03 was 2785. So now I have these three in my notepad. We're going to double check the folder here. So we started with, let me select 91 selected frames. And when we have gone through the inspection and approval process, we have 73 frames remaining. Now keep in mind, if this would have been a real project, I would probably have gathered the data over several more sessions and discarded a lot more of these frames with a high number of FWHM, I would say. The next step is to register the light frames. For that we use the star alignment process. You can find it in process, all processes, and star alignment. Now, this is where it gets interesting, and you really need to keep an eye on things, because if you're doing this with a color camera, you would not have to worry about different filters like I do now when I do mono. But the basic rule is to first make an output directory. I have made one here in the same directory structure as before. I used this folder to store my calibrated flats first. I used this folder to store my calibrated lights. And I have this folder for my registered lights. I should, of course, have put my approved folder here, so I will actually move that to not confuse you. I'm going to paste it there, so I have under my calibrated lights folder, I have my approved light frames as well. Registered lights. This folder has been created and I've pointed out to it I always use the same folder. I'm going to add my files now. I'm going to use my calibrated and approved light frames. I make sure that I'm in the right directory. I also make sure that I have the postfix _C and _A. That stands for calibrated and approved light frames. I'm selecting all my HA here. I open them up. I'm going to select a reference image. I'm going to my calibrated and approved frames. I'm going to select the best HA, 2751. So I'm scrolling down to HA 2751. Now, just to simplify or complicate things, please note this is very, very important. For this type of scenario where you have three different filters, you would want to keep the reference image the same. So for HA, O3 and S2 filters, you are going to use the same reference image when doing the star alignment process. If you don't do that, you will have a hard time combining the different filter frames later on. So make sure that you keep the same reference image. Later on in the next step, when we are going to actually integrate our light frames, you will have a different reference image for each single filter batch, so to speak, but that is entirely a different matter. We're going to come to that later. So the best quality HA light frame for your reference image. You can also do some configuration here. If you're going to be using drizzling, I'm not going to go into dithering and drizzling discussions in this video, but if you're going to drizzle your images, you select this. I'm not in this case, I'm deselecting the generate drizzle data just to avoid having all of these files in my directory. I double check that I only have HA and that I only have my approved frames. I can do some adjustments if I want to on my star detection. I think I might have edited these numbers a bit. Detection scale 6, noise scale 1, minimum structure size 0, hot pixel reduction 1. You can copy these settings if you want to. I'm not exactly sure right now if I changed any of these or if they are default. I'm sure though that I changed the ransack tolerance or the ransack iterations for the star matching settings. So you can keep it at default or you can copy my settings. I've most certainly copied my settings from in a number of other people's YouTube videos, and by trial and error seen what works best for me. So a quick recap. Reference image, the best H-alpha quality image selected. All your target images or frames, the same. First filter H-alpha, the output directory selected, and then you click on the apply global. When the process has completed, you can check in your registered light folder to see. As you can see here, I have 35 registered files, and we have a new postfix _R. So now this frame is calibrated, approved, and registered. And all of these 35 light frames for the H-alpha filter have been star aligned. So I clear this and click on add files. Go to the approved folders if I'm not already there. I select my 03, 18 frames, but important, I keep the H-alpha reference image. And then I click on apply global, also keeping the same output directory. And when that is completed, I check my folder again. Yes, I have 18 registered new files. Click on add files, go to my approved frames, and then select my S2 frames. It's 20. And again, keep my HA reference image, keep my output directory, and then press the apply global. And the final step, or the final filter, is finished and the S2 frames have been registered, I can close the star alignment process. Now for the final step, I want to integrate my light frames. And I use the same process, image integration. And I have one configured here for the light frames integration. If you want to gather data during several sessions, I would suggest stopping at the calibrated light frames step and then gather as much calibrated light frames as you can, and then run the register light frames or star alignment process on all of these calibrated light frames from different sessions. I will also suggest that you use the subframe selector and approval process on all of the calibrated light frames combined in order to get the best possible data. And don't use approved frames from each session individually. Now, starting with add files. Now we go into our registered light folder that we created and where we put our registered light frames in the previous step, starting with our H-alpha filter light frames, making sure that we have just H-alpha and our correct number. And this is where we use the best, again, 2751. So the 2751 is the one that we think is the best frame. I will select that and I will click on the set reference. That will put that frame in the top of this list. Now we have some different settings. We have image integration settings, a combination of average, a normalization of additive with scaling. For weights, we don't want to use the PSF signal weight. We actually want to use a fits keyword. Now, if you remember, this fits keyword was SS weight. And this is important because you want to use the weighting number depending on the weight expression that we put inside the subframe selector in our approval process. And this will weight the frames according to the number in that fits keyword. We want to use the by weight mid variance scale estimator, generate integrated image. We also want to use evaluate SNR, and the rest of these settings are default, I would say. For the pixel rejection, we still use a linear fit clipping. If you're using less images, like we said, if you read this, you can use other rejection algorithms depending on the number of frames that you are using. We want to have a scale plus 0 offset on the normalization, and I'm not sure if I have changed these or if they are default. I think they are default. You can check that. No settings for pixel rejection 3 and no large scale pixel rejection settings whatsoever. So remember, H-alpha frames, select the best image as your reference. Select weight keyword to SS weight and select weights to your fits keyword. And then click on the apply global button. So when this has completed, you can discard of the rejection frames I will save the suspense of stretching this until later when I can compare. I'll go into my folder and Master Light HA and close that. Clear the data, add files, select my O3 frames, make sure that I only have O3 frames. I will check 2785 is the one that I consider best. I will select that and set reference. I still have the fits keyword. I still have SS_weight as the weighting keyword. Then I will click on Apply Global. And when that is finished, discard of your rejection files. Save that as Master Light 03. Close that, clear your data, add files again, and the last step, add your S2, 20 frames, look at this number, the best frame is that we consider to be 2807. I will select that and click on Set Reference. The settings remain the same. Still fits keyword SS_weight for the weighting and click on Apply Global. And for the final master light, we shut down or discard our rejection files. We click on Save As, Master Light S2. Now we can close that. So now we have gone through all the different steps of the pre-processing, both in part 1 and part 2. Let me show you some files here now. We're first going to open up, let me select the best one, 2751. Yes, that was one. This is the first and single light frame. Then we calibrated the light frames. And then we integrated all of the light frames into a master light for HA. So let me show you what they look like here. First we have a single uncalibrated light frame with the HA filter and the amp glow. Then we calibrated this light frame. It's still a single light frame, but we have calibrated it with our master dark file and our master flat file that we integrated using the dark flat frames for that filter. And then we ran through the star alignment process, aligning the stars on all of the light frames for the separate filters. And we integrated all of our approved light frames into this master light, also using the weighting that we configured in our expression in the subframe selector. And if we stretch this one, this is the result of our integrated master light for the HA filter. Now this is of course completely unprocessed, and in part 3 and 4 of this PixInsight tutorial, I'm going to walk you through the nonlinear and the linear processing of this image to further bring out details, of course, remove background here, and also combine the different filters for H-alpha, O3 and S2 to make a Hubble palette image. We can also just look at the other master lights just for fun of it. This is the O3 and this is the S2 master light for this Rosette Nebula. So I will see you in the next part of this PixInsight tutorial. Thank you so much for watching this video and my PixInsight tutorial series. If you like this video, please consider subscribing to my channel, and if you have any requests on upcoming content, please leave a comment. Until the next time, I wish you have some clear skies.